Hey everyone, it's Chat here. Today we are tackling the LeetCode problem 33, search in rotated sorted array. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan, to coding, then testing for errors and evaluating time and space complexity. I'll be solving this problem in Python, and I'll be thinking out loud and ask clarifying questions as I would do in a real interview scenario. Let's get started. So, first of all, to understand the problem, let's start by reading the problem statement. So, there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, where k is between 1 and nums length -1 included, such that the resulting array is nums k, okay, k plus 1 to k minus 1. So it is, the array is 0 indexed, and we know that k is at least equal to 1. So we'll have nums of 1 here, nums of 2 here, and in the end, we will have nums of 0, for example. 0 to 7 can be rotated to 4, 5, 6, 7, 0, 1, 2. Okay. And given the array nums, after the possible rotation and an integer target, return the index of target if it is in nums, or -1 if it is not nums. And we want to write an algorithm with O of log n runtime complexity. Okay, so first of all, my first question would be, so yeah, we can have any numbers in there, but they are sorted, right? And the numbers, I would ask the following question, that is, what are the limits for the given numbers? And we do have the answer in the constraints that it is between 1 and 5,000, right? One thing to note here is that we know that all of these values are distinct. Okay, let me first go through an example to better understand the problem. So let's take this example 1 from here. So if nums is this one, and we want to find the target 0, how would I solve it? So we have 4 here, we have 2 in here, so we want to find if 0 is part of nums or not. Let me first try to solve a simpler problem. Let's say I could sort this one, right? If I could sort this one, I would have 0, 1, 2. Then I would have 4, 5, 6, 7. And the way I would have solved this problem is through a binary search. And whenever an array is sorted, we know that we can use the binary search, and also the expected runtime complexity helps us think of binary search. So how the binary search works is, so we get the length of this array that is so 0, 1, 2, 3, 4, 5, 6, 7. Sorry, 3 here and 4 here, so 7 in total. So we would just divide it by 2. That gives us 3. So 0, 1, 2, 3. This would be the middle, and we check if it is equal to the target, or if it is higher than the target, or it is lower than target. If it is higher than target, we know that the answer is to the left, and else we know that it's to the right. And we divide in the array 2 by 2 and get our answer. Here, the problem we do have is that there's a given k that rotated the array. So if I do the same thing here, let's say I take the middle of this one, right? So 3 to the left, 3 to the right. So this would be the target. And we can see if 0 is lower to the target or higher than the target. Is 7 higher than target? Yes, it is. So we should go to the left, right? And then we would go here, and then we would go here, and there's no answer to the left. What we could do here is we could also go to the right. How would I solve this? With the O log n runtime complexity. Let me think about this. Let me just take this array here. Let's say I could repeat it, right? This way. And what we want to know is if the target is in there or not, because we'll be returning the index of the target or -1 if it is not there. And here the problem, so I could not apply the binary search here. Sorry, it did not, doesn't make sense to actually apply the binary search here because the array is not sorted. The easiest way I do see here is to actually, find the k with the possible rotation. So I could just, iterate over it this way. How could I find, say, if I could find the index of k, if k is known, then it is pretty simple. I could consider actually, you know, the array starting from k plus 1, from k. My bad, no. So it would be so in total, if we start from k here, we have k, k plus 1, etc. to n minus 1, right? So here we should have in total, we would have here n minus 1 minus k plus 1. Yeah, this gives me the index. This is the index from where we have the 0, right? So, and then after this one, I would have all the others. But my question here is, how could I find this? The easiest solution is to iterate over nums and find whenever we find, the first time we find I minus 1, nums I minus 1 is strictly inferior to nums, strictly superior, sorry. If we find this, if I n minus 1, so for if I between n minus 1 and 1, I do find this I, verifying this condition, then it was rotated. It just means that it was rotated, sorry. Else, we know that we can simply sorted array and we can simply apply the binary search. So is there a way to actually find this this k, this I, where for the first time we have this, 7 being higher than 0. For me, if I go through the whole array, it would be O of n, right? Is there a way to find it in a better way? Let's say I have this, I cut it in 2 and see if this is the largest one we know, right? Oh, I do see a way here. Let's say I have 4 and 2, right? 4 is strictly inferior to 2, right? As 4 is strictly inferior to 2, what does this mean? It means that the I we are searching for is in between, right? So we can cut this in 2. We can say, I'm considering 7, and is 7 is strictly inferior to 2? If, sorry, my bad, it was the opposite here. It was the opposite here. As 7 is strictly superior to 2, it still means that the I we are searching for is in the middle. So we can choose this side. This becomes the new interval we are considering. Now that I know this, I can cut this. So I have 4. 4 divided by 2 is 2. So 0, 1, 2. So I have 1 and 2. 1 now is strictly inferior to 2. So it just means that I should not consider this interval, but the interval just before that one. So we are looking for 7 that is strictly inferior to 0. And we found k. K is, we found I that is equal to the index of the right side, 1, that is 0. So this gives me 0, 1, 2, 3, 4. This is 4. So as do we have index is 4, well, let's just check. As we know that k is equal to k is equal to 4 here, and we have in total k is equal to 4, right? And n is equal to n for length of nums is equal to 7, and seven minus I can maybe check this within another. So I think, okay, let me give my overall solution here first of all, because now that I've well understood the problem, and I do have a plan to solve this problem, because I will proceed. Let me clearly explain this one. So here we go. This is the input example 1 that I'm considering. And the way I'm going to proceed is in 2 steps. First of all, I want to find k. So that O simply, because I know that the number of elements that I do have here is n minus 1 minus k plus 1, that is n minus k elements. N minus k elements or n minus k, because this gives me the number of elements before the smallest number, and also the index, because if I have n minus k elements here, 0, n minus k minus 1, and this one gives us, and this is also, this also gives me the index of the starting. In nums, right? And then step 2, now that I know now that I know this, I can consider, whenever I'm looking into nums of I can add n minus k, right? And modulo this would be modulo n, right? This would simply, I can still use my binary search by translating this way. And here I will use binary search I will use binary search twice. There we go. Now that I do have the solution, let me code this one. So I do have I do not have any specific questions on the on the elements in nums, because they do not really matter here. As we can see here, they're between minus 10 to the power 4 and 10 to the power 4. So yeah, that works. So first of all, but the thing is, the first and the second binary search do not work the same way. That's the thing. So let me find n minus k first, right? And so let me just, execute this. Let me test this with this example. So to find k, what I did was 4, 2. If 4 is strictly superior to 2, then I divide by 2. The length, that is 7. 7 divided by 2 is 3. So I get this one. This is still bigger than 2. So I choose this one. And then this is still bigger than 2. So I choose this one. And this one is lower than this one. So I'm choosing the other side. And as I do have this, I know that the one to the right is the solution n minus k, and this is equal to 0, 1, 2, 3, 4. So n minus k is equal to 4. And as n is equal to 7, we get k is equal to 3. And is it right? 0, 1, 2, 3. Because k is 0 indexed. Right, so it works. Now that we do have this, what I do then for the second step is simply I add 3 to my nums. So 0 plus, n minus k, that is 4. My bad. I'm not adding n minus k here. I'm adding k here. Because 0, 1, 2, 3 is the 4. Yeah, right. Now that I add 4, no, it should be n minus k, sorry. Because nums is already rotated, So I'm adding 4 to this one. That gives me 0, 1, 2, 3, 4. This is the first value. This is the second value. So we are comparing this one with this one, and we divide by 2. The result. So and so yeah, the length between this one is 7. 7 divided by 2 is 3. So we say we are looking into 3 plus n minus k. So 3 plus 4, which means that 1, 2, 3, 4. This is the middle. Am I right? 0, 1, 2. Let me put this way. So there we go. We have 7 values here, and 3 to the right, 3 to the left. And I should add k equal 3. It's not n minus k. It is, well, k, because if we add k, so we get 1, 2, and third one. Yeah. Sorry, what I mean by that is, for index 0, I should add k here because I know that this position is n minus k, right? If this position is n minus k, I should add k so that it makes n. Oh yeah, n minus k. I should add k so that the modulo of this one, the whole thing, gives us 0. Yeah, so we should add by k. So yeah, using this example, we've made sure that of the different indices we will be using here. Now let me code this one. Okay. So I'm gonna start with left and right. Well, left is gonna be 0 and right is gonna be length of nums minus 1. And I'm gonna call length of nums n so that we can simply use it later on. There we go. And while left minus right, so there's one thing I want to make sure here is that if we do have nums of length 1, well, it's pretty simple, right? If it corresponds to the target, we can immediately say yes, else we return -1. Why do I want to do it? Because with this binary search, I really want to keep at least length of 2. So let me confirm it here. If n is equal to 1, return -1. If target is equal to nums of 0, else -1. There we go. So yeah. While left right minus left, the length is strictly inferior. Should it be superior or equal to 2? I can say something like is strictly superior to left plus 1. What am I trying to search for here? I want to search for k. We are searching for k that is superior to 1 and inferior, strictly inferior to n. And now that we have this length, and yeah, I could continue as long as I do have an interval. So let me call this find k, right? And for this, I'll be giving nums as an input. I'll be giving left, right, do I need this actually? Yeah, it can be a good idea to have this method so that I can return as soon as I find. So I could. So what is my condition here? I just want to. Sorry. So I start with this one, right? I just wanna, let me implement this simply first. I wanna get nums left is strictly superior to nums right. Is it This should be superior to this. If nums2, what does this mean? If this is equal to, if this is strictly superior to this one, it means that I can get the middle. Right? So if this is superior to this one, I get the middle. If mid is strictly superior to then we choose mid. Becomes left, so that we can look into the right side. Else, there's no way this will be equal to this one, because we know that the elements are distinct. So we have mid that becomes right. Because what does it mean? It means that nums mid is strictly inferior to nums right. For example, if we take this one, mid is inferior to right. So the answer is on this side, right? Yeah. And we do this while and left right minus left is strictly superior to 1, which means that there is at least superior to 0, right? Because 1, because we do not want to divide it the last one time. So we have this. So I start with right and left. And because that right minus left is strictly superior to 1, mid is this. And if this, we get this. And we will be returning. So we have the answer. So k is going to be n minus so our right is equal to n minus k, as we saw earlier. So k is going to be n minus right. Exactly. And now that we do have this, let me just test this if this works. So we start with, we eliminate the case where nums is equal to 1, length of nums is equal to 1, and then we start with left equals 0, right is equal to n minus 1, and we do Well, this is the case, and right minus left is strictly superior to 1, which means that we have at least one element in between those two. We divide by 2, we get the middle, and we see if this one is strictly superior to this one, in which case we say that left is equal to 7. Yeah, not 7, but the index of that, and right is equal to mid. And once we've found this one, we can actually do something like k is equal to n minus right. Now that we do have this, we can solve the problem by doing the following. So this was the step 1, right? Find k. Now that we do have the solution, we can do the step 2. That is find target. And what we do here is we set up we start with left and right being 0 and n minus 1, and we are doing the same thing here. While left actually I do not need this. I can have this way, and if we have this, if nums left is strictly, we know that k is equal to 0. We do all this, right? And for this one, we would do, while left is strictly inferior to right, we want to find the target. We calculate the mid. That would be left plus right divided by 2. If nums mid equal to target, this is not just mid, right? We should add k as we noted here, and modulo, do the modulo. If nums mid is target, we return mid, but real. We would return real mid, else if we have real mid is becoming we'll be returning actually -1 if we do not find something. But the thing is, if real mid nums is strictly superior to the target, what does that mean? If this one is superior to the target, we should go to the left, right? Target is somewhere to the left. So right becomes mid, else left becomes mid +1 -1. So here we go. Let me just try this example on, let me run this code with an example 2. With example 2, that gives me, let's copy this and paste it here. There we go. So I'm starting with left and right equal to 0 and n minus 1. So n is 3, 4, 5, 6, 7. So we get left, right is equal to 0 and 6. Then what happens here? We know that n is not equal to 1. If it was, we would return 0 if target is equal to nums, else it's not in there. As it's not the case, we just check that if nums left is strictly inferior to right, which means that the whole array is in the ascending order, in which case k is equal to 0. Else, we do something, which is the case here. 4 is strictly superior to 2, so we end up in this spot, while right minus left, so we have at least one element in between. We determine the middle, that is 0, 1, 2, 3 here, and 3 gives me this one, and I check 7 is strictly superior to 2, so left becomes mid. We check this one, and now 4 divided by 2 is 2, 0, 2, so I check this one. 1 is strictly inferior to 2, so we choose the left side. So it's the right that becomes, oh, my bad. So when I check this one, I saw that this one doesn't, verify it. I choose this one because right is equal to mid. And now I'm checking this one to this one. And as this one is lower than 1, we are going to the left. So right becomes mid. And we are proceeding this way. So 7, 0. And here, because it is, and as we've ended up with right and left, and there's no single value in there, we end up showing the index of 0. That is 4, right? 0, 1, 2, 3, 4. So k is n minus k is 4 because it's right. And k is then 7 minus 4 is 3. Now that we do have this result, we reinitialize left and right, 0 to n minus 1, and we calculate the middle of that. And once we have the middle, that is 7 divided by 3, it's 3. Sorry, 7 divided by 2, that gives us 3. We add 3 to it. By adding 3 to it, 6, 0, we know that this is the, let me just rearrange the array from above so that we can confirm the result. 7. There we go. So 6, it should be 0. So 0 is 4. And if we divide this one by, we have 3 to the right, 3 to the left, and the answer is 4. And is 4 the target? No, it is not. It is even higher than. So we go to the left. So our right becomes mid minus 1, right? Is it a good thing to actually so mid minus 1, and our mid was actually sorry, mid was 3, so mid minus 1 is 2. So now that we have 2 to the right and 0 to the left, 2 to the right, 0, 1, 2. Sorry, 2. Sorry, here. 2 is here and 0 is here. We check if we do have 3 here. No, it is not the case. So what do? We increment 1, and so we end up with the singleton 2 by the end. And as it is not equal to the target, we end up completing the while loop, and we'll be returning the results. So there we go. Yep, it passed all the cases. Let me submit this. So there's one problem with one, 3. Let me add this test case here. Let's try it out. Why is it failing? So we have 1, 3 here, and the target was 3, and the output we've returned is -1 rather than 1, right? And here normally, as this is a sorted array, I should simply have so we do have a problem here because so k is equal to 0 normally here. So this is not the one normally that is leading to this error, but this one. We have 2. We divide it by 2. So it is 1. So 0, 1. And 1 modulo n plus 0 I just want to check if right is n minus 1. So divided by 2, that gives us, so 2 divided by 2 is 1. So 0, 1, this is the mid, which is equal to real mid, which should be just 1. And if real mid is equal to the target, we should just return real mid, right? I just want to print out real mid here so that I can see what I'm. So what's surprising here is that this test is not. Oh yeah, it's not passing. Yeah, wait, what? Oh, sorry, the target is different. Let's run this one. This is where we do have the error. Yes. And we can see here, what did I print out? What did I print out here? So I printed out real mid. And I want to print out also K. Just to see that I'm literally getting 0 normally. Yeah, K is equal to 0. There's no problem with this. Here, I have real mid that is printing out 0 because 2 divided, oh yeah, it's 0 plus 1, sorry. 0 plus 1 divided by 2 is 0. 0 plus 1 is 1, so divided by 2 is 0. That's it. So we get the 0, right? And then what happens? If this is the target, we return it. Else, oh, that's a simple problem here. Yeah, it's just because we should not end up here. Now it should work because we should go up until, yeah. We can have a singleton here. I have another problem here. Okay, let's try to understand this third problem. 3, 5, 1. So if I look into this, 3, 5, 1. Well, first of all, 3. So I have this. I want to find K, right? Okay, finding K is the first sub problem. And K here, n minus K should be 2. Do we find 2? 0, 1, 2. And then for the solution, we are outputting -1, while 5 is there. So if I divide this into 2, so I have 3 as length, and divided by 2 is 1. So 0, 1, 0, 1, and this should return immediately the target, right? And why didn't it? Oh, sorry. What did I do here? It should be 3 and 5, sorry. I miss 1, 3, 5. And is 3, so 1, 0, 1. So this is not the case. It is not in there. So what I do is I increment. So left becomes, because this one is not working, we increment so this one. So left is becoming mid plus 1, which is equal to I just want to print out real mid with this test case that is 1. Real mid is 2. We got 2, right? I mean, sorry, print k first. Print k is equal to 1. Oh, there's a problem here. K should not be equal to 1 here. I'm not sure how this works. Let's try to review this. Let's go from the beginning. So to solve the problem, I first try to find k using a kind of a binary search, right? Yes, and I checked if we only had one value in nums. This is right. If nums left is strictly inferior to nums right, in which case the nums array isn't sorted in ascending order without being rotated. And here I kinda use right minus left. Let me maybe I think there's a problem with this one here. Let me rewrite this. If I could say if left is strictly inferior to right, I get the middle. So we go up. So as long as we at least have 2 values in the considered interval, we proceed. I compute the mid, that is left plus right divided by 2. So if we only had 2 values, then the mid will be here to the left. because 2 divided by 2 is 1. Um, sorry, what I meant was, so it would be 0. This one would be 1. So 1 divided by 2 is 0. So it's a 0 index that is given by mid. And if nums of mid is strictly superior to right, it means that left should become, so if we had this, right, if we had 3 elements in the array, I mean in the considered interval, and mid is this one, and if this one is strictly superior to this one, as we're searching for the first element that is strictly inferior to the one before, we don't care about the 4, right? I mean, sorry, we should maybe consider this error here. We should not carry. We should not care about the 7. We should move to the right. So we can say left is mid plus 1, right? And if we are in the situation where we have this interval that is considered, 0 is strictly inferior to 1, well, right becomes the index of 0, because this one might be the result. And let's say we end up in the situation where we only have 2 values, where it's the last time we will enter into the while loop, and mid will give me this one, and this one is strictly superior to this one. So we would increment left, right? Left becomes mid plus 1, and so yeah. Yes, so that's good. And I think there's a problem, maybe. Yeah, I think the index of k, yeah, yeah, I can do this. So I could simply use left here. Actually, now that I think about it, there's one problem here. Now that I think about it, well, left and right are actually, the real indices. And why did I have to do n minus left? Because let me submit this to see if everything is working fine. Okay, the same one fails. Let me just replace this with maybe left, because actually we found the solution with this one, right? Yes. Okay. Because with this while loop, actually what we did was actually find the the index of the first element so I should not call this k actually. Yes, this is not k. K is not actually equal to the rotation index as presented in the description. I should call this something else because that's what actually made me, mix n minus k and k. So I should not call this k. Let's call this L. And L is actually the number of elements before the smallest. And this is L. So yeah, I actually mixed up things because I named the variable, this new variable that is n minus k L as being k itself, and that's why I ended up mixing both of them here. So yeah, so let me just so this gives us the result in for this problem. And in terms of time and space complexity, of 1 for space complexity, because we are not having any arrays, or we're not storing anything, rather except in some constants. I mean variables, simple variables. And this one is O log of n, where n is the length of norms. And the same goes for this one because we're just doing 2 binary searches here. And the times is O of log n. That satisfies the expected runtime complexity. This sums up. Yeah, that's it.